Okay students, let's now start dealing with the questions which arrive in the section B. Now here question number 5, happening to be the first question in section B, is going to test your knowledge on LMVT, which is the Lagrange mean value theorem, as you can see. Its short form is LMVT, Lagrange mean value theorem. It is saying and asking you to verify LMVT for this particular function on this very interval. Also then further it is saying find a point small c in this indicated interval, which is nothing but 1, 3. Now you won't be able to deal with this question and attain the exact correct answer until and unless you are very clear with this concept of what is LMVT. What does it say? It says that if f is a function defined on a very closed interval AB such that it satisfies two conditions. One is, suppose this f is continuous on this open interval AB over which it is defined, and the second quality which it possesses is that f is differentiable on open interval AB. Then the concept says of LMVT that there exists a real number c belonging to this open interval AB such that f dash c is equal to fb minus fa whole upon b minus a. Once this concept is clear to you about LMVT, then only you will be able to deal with this question. The function f over here is being played by x into x minus 2 and the closed interval AB is being placed by the closed interval 1, 3. Let's see if this very function satisfies the LMVT conditions or not. Because only then can we proceed. That is what the question is asking you to verify them. So now we have f of x equals x into x minus 2. Sort this out. This happens to be x square minus 2x. Now this is a very beautiful function. It's nothing but a polynomial, and polynomials are everywhere continuous and everywhere differentiable. No hassle about it, no cloud of confusion about it. So obviously if this is everywhere continuous and everywhere differentiable, that means this function is definitely continuous on our indicated interval 1, 3 as well. And also because it is everywhere differentiable, that means definitely it is differentiable on our indicated interval, which is 1, 3. And so this is satisfying the hypothesis of the LMVT. That is why, therefore, there will exist a real number small c sitting in 1, 3 open interval such that this f dash c is equal to fb minus fa upon b minus a. Now you should know what is a and what is b. A comma b made the closed interval, so a happens to be the first, that is 1. And b will be the next end point, which is 3 of this interval. So, what is f dash c, what is fb, what is fa, what is b minus a? We are just going to pick these values and plug them in here. Now, f dash x turns to be what? Fx is x into x minus 2, which is x square minus 2x. So, f dash x turns out to be 2x minus 2. This means once this is done, I am just going to replace x by c and plug this entire expression over here. What is fb? What is fa? F of x is x square minus 2x. So f of b, which is nothing but f of 3, is 3 square minus 2 into 3. 3 square is 9, minus 2 into 3 is 6, so this delivers you with a 3. And what is f of a, which is f of 1? F of 1 is 1 square minus 2 into 1, which is minus 1. You have fb, you have fa, you have b, you have a, you have f dash c. Just plug in the values. So then f dash c is 2c minus 2, because f dash x is 2x minus 2, so f dash c is 2c minus 2. Then what happens over here? You get 2c minus 2 is equal to f of b. F of b is 3 minus f of a. F of a is minus 1, so this becomes plus 1 whole upon b minus a, which makes it 3 minus 1. And what is it that you get? You get 4 upon 2, which delivers you with a 2. You get 2c minus 2 equals 2, which gives you 2c equals 4, which gives you c equals 2. Now LMVT for this function f is delivering with this value of c. But if you recall the concept I had just written, this c should sit inside the open interval a comma b, in this case the open interval 1 comma 3. Until and unless this c sits inside or comes as an element of that particular 1 comma 3 open interval, I cannot say my LMVT is satisfied. Over here this 2 is very much coming from this interval. That means completely this function f on this interval 1 comma 3 satisfies LMVT. That is what is the solution of this question. And hence the very point C, which should lie in the indicated interval, is C equals 2. Once this question is clear to you, which was just using your very simple direct concept of LMVT, let's see what happens to be the case with the next question. Now the sixth question is saying, determine the order, okay, fine, order is asked over here. Determine the degree, fine, degree is also asked over here, of this differential equation. What is the differential equation? This one. It's given to you over here. State if it is linear or non-linear. Now so many terms are over here. Linear, non-linear, degree, order. Your concept is, which is used over here, are the meaning of all these terms. You should know what is the meaning of order of differential equation. What is the order of differential equation? The order of the highest order derivative in that differential equation is the order of the differential equation. Next, you should know what do I mean by the degree of a differential equation. Well, the degree of the highest order derivative in a differential equation after it is made free from radicals and fractions is what is the degree of differential equation. So this should be clear to you. The third concept is, obviously I should say, when is a differential equation non-linear? This you should know. These three things you should know, and then you will be able to sail through this question. When is a differential equation non-linear? When you have one among these four conditions happening. If you have degree of the differential equation is greater than 1, then it is non-linear. If you have terms which are nothing but product of, or which involve product of the dependent variable and the differential coefficient, then your differential equation is non-linear. If you have exponent of the dependent variable greater than 1, then it is non-linear. And if you have any of the differential coefficients in the differential equation with exponent greater than 1, it is still non-linear. If any of these four conditions you find in this differential equation, you will declare it to be non-linear. And if they do not exist, then they are linear, or this equation is linear. So now next we will have to, obviously, in order to find the degree of this differential equation, we will have to make it free from the fractions, right? For degree, we need to make the differential equation free from radicals and free from fractions. So what do I do? Well, I have 1 plus dy by dx whole square whole to the power 3 by 2. This is equal to k times d square y by dx square. Now you have 3 by 2. In order to remove this fraction, you will have to multiply by 2 so that this denominator 2 gets cancelled. So the next step will be squaring both sides. And what does this deliver? Well, you square the right hand side, you get k square d square y by dx square whole square. And here what is it that you get? You get 1 plus dy by dx whole square the whole cube. That is what happens when you square the left hand side. Now this differential equation is free from radicals and free from fractions. The highest order derivative that you can see is d square y by dx square, and therefore order of this differential equation is 2. What happens to the degree? The degree is nothing but the degree of the highest order derivative once the differential equation is made free from radicals and fractions. So over here the highest order derivative is this and its degree is 2, and so degree is also 2, which is greater than 1. That means it is a second order, second degree differential equation, and that is why it is definitely non-linear. So we had to state if it is linear or not, so it is non-linear. Once this question is accomplished, and we saw that this was very, very easy because it just used the very meaning of all the terminologies which are stated in this very question. Very easy, very direct. Let's see what happens to be the next question. The next question says, find the equation of the line passing through this point and parallel to this plane and this plane. Oh, so many pieces of information are given to you. Don't forget what you have to find. You have to find the equation of the line which is satisfying two conditions. One is it is passing through this point, and second condition is it is parallel to these two planes. Now again, a concept which is based on this particular question, or the question is based upon whichever concept, is that the equation of a line passing through a point whose position vector, you can find position vector of any point, is suppose A vector, and parallel to a vector B vector is given by R vector equals A vector plus lambda times B vector. Yes. To find the equation of a line passing through a point whose position vector is A vector and parallel to B vector is given by R vector equals A vector plus lambda times B vector. That is what is the rule or the concept, the tool which is going to come to rescue, to help us deal with this question. We are already given a point through which the line is passing. So I have my A vector with me. What is my A vector? A vector is 3i cap plus 0j cap plus 1 k cap. The position vector of this point is this. Now understand, the line is parallel to two planes. I want the line to be parallel to some other vector, which is B vector. I don't have that directly in picture. My line is parallel to these two planes. If a line is parallel to two planes, that means it is perpendicular to the normals of those two planes. Now what is the normal of the first plane? This is the first plane, so the normal is I cap corresponding to this x plus 2y, so this becomes plus 2j cap plus 0 times k cap. And then what happens to the normal of the second vector, of the second plane? This is 3y minus z. This gives you 0I cap plus 3j cap minus k cap. That means if the line is parallel to these two planes, it is perpendicular to the normals of these two planes. Correct? That means your A vector is normal or perpendicular to this normal, and your A vector is perpendicular to the next normal as well. Now, one thing that you have to recall is another certain concept based upon the cross product. What is the next concept? That A cross B, when you find out cross product of two vectors, is a vector, obviously this everybody knows, is a vector which is perpendicular to both A vector and the B vector. The cross product of two vectors is a vector perpendicular to A and B. That means n1 cross n2 is a vector which is perpendicular to n1 also and n2 also. Why am I going to do that? I'll just explain that to you. Let us now find n1 cross n2. How is that found? I cap, j cap, k cap. N1 is what? 1, 2, 0 is what's supposed to be written over here. And what is N2? 0, 3, minus 1. Solve this out. What is it that you get? 2 into minus 1 minus 0 minus j cap. What is it that you get? 1 into minus 1 minus 0 plus k cap. What is it that you get? 1 into 3 minus 0. And this gives you minus 2I cap plus j cap plus 3k cap. You have found this cross product of the two normals. And this cross product is a vector which is perpendicular to n1 also and n2 also. And if n1 cross n2 is perpendicular to n1, which is perpendicular to A, that means A is parallel to n1 cross n2. We have A is parallel to n1 cross n2. Take this as your vector B. What is it now that I have? Well, the line is passing through the point A, whose position vector is this A vector, and parallel to the line or parallel to the vector B, which over here is n1 vector cross n2 vector, this cross product. Then, once this all is known, we know what is the equation of our line. Then the equation of the line is what? It is given by R vector equals A vector. So what is your A vector? It is 3I cap plus 0j cap plus 1k cap. A vector plus lambda times B vector, which is n1 cross n2, which is minus 2I cap plus j cap plus 3k cap. Where lambda is any scalar. This is what is your solution. You can even try and convert this in the Cartesian form in the form of x and y, and then even that can be your solution. That's how we have dealt with this indirect question. The concept which I told you while solving this question are the concepts which basically make this question a cakewalk for you. And that is how this question is dealt with. Let's see what happens to the next question. Here it is written, find two vectors, or if two vectors A and B are unit vectors. That means they are one unit apart from the origin. Their magnitude is 1. inclined at an angle theta, then prove this particular claim. Something very, very easy, very straight. Why? Because I'm just going to pick this portion up. Here you have a cap minus b cap. If I take the square, what happens over here? You get this square minus a dot b minus b dot a plus mod b square. That's what is the formula. That's the concept you require. You should know the formula of this particular expression. Something very easy. In fact, after this also another concept is used, that the dot product of A and B and A is equal. And that is why this turns out to be what? This turns out to be this minus twice of A dot B minus this. Once this is obtained, what is the next thing you can do? Well, another concept which is required, let me write that down. The first thing we needed was that any vector you have, the concept is A dot B is equal to B dot A because dot product is commutative. The next concept I had already told you, you should know the definition of the dot product. It is nothing but the product of the magnitudes of these two vectors multiplied by the cosine of the angle theta, where theta is the angle made between these two vectors A and B. These are the concepts which will be used. Why? Because over here I am going to write, now A dot B, I have the formula. This is mod of A vector, mod of B vector into cos of theta, where theta is given to me, minus this. Now you know that A and B are unit vectors. So this is equal to 1 square, which is 1. This is 1 into 1, which is 1. This is 1 square, which is again 1. So you get 1 plus 1, that is, here it's plus. So 1 plus 1 gives you 2 minus 2 cos theta, because this is 1. So you get 1 plus 1 minus 2 cos theta, which delivers you with 2, 1 minus cos theta. Now another concept. Why? Because the very question is asking you about the ratio sign. But we have got the ratio cosine. How to convert from cosine to sine? Well, the concept is 1 minus cos 2 theta equals 2 sine square theta. See what is happening in this formula. Cos is getting converted to sine. Here you were having 2 theta, now it is becoming theta, half of 2 theta. Therefore, over here if you have 1 minus cos theta, won't it become 2 sine square half of theta, which is theta by 2. And that is how, by using this particular formula, I have brought sine into picture, and that is how I have got 4 sine square theta by 2. Now that I have this equals this. So 4 sine square theta by 2 is mod of A minus B whole square. And then after this step, what is it that I have? I have mod of this A vector minus this B vector whole square multiplied by 1 by 4 is equal to sine square theta by 2. Right? That's what I can do. I can take this 4 over here, becomes 1 by 4, and my expression comes out to be this. Somehow we are close to obtaining what we want, but this 4 should become 2, this 2 should vanish, and somehow this 2 should also vanish. Why not take the under root? Well, when you take the square root, what happens? You get 1 by 2 mod of these two vectors, the square vanishes, and here you get sine of theta by 2, and that gives you your solution. The question is, why not the minus sign come over here? And the answer is, the theta which is allowed to be between the vectors, two vectors, ranges from 0 to 180, because that is the principal domain of the cosine function, which happens to be sitting over here in the formula of dot product. If this theta is allowed to be from 0 to 180, that means theta by 2 is sitting between 0 to 90. That means theta by 2 is an angle in the first quadrant. And in the first quadrant, sine ratio is always positive. That is why there is no negative sign. You take the under root, you get directly the expression which you wished to prove. That is how this question is supposed to be dealt. Just these three concepts and you are going to sail through this entire question. Let's see what happens to be our next query. Keep yourself clear with the concepts that I am writing, because they are the ones which are going to help you deal with any question based on the same idea. Question number 9 is, okay, let's read it carefully. It's a big question. It is known that if the interest is compounded continuously, the principal changes, okay, now this is important, the principal changes at the rate equal to the product of the rate of the bank interest per annum and the principal. What did it say? It said that the principal changes at the rate, so principal is changing at a rate. Suppose P is the principal, T is the time. Principal is changing at the rate equal to what? Equal to the product of, okay, so something related to product is coming. Product of the rate of bank interest per annum. Now the rate of bank interest is denoted by R%. This is the rate. Product of the rate of bank interest per annum and the principal. Okay, we have interpreted the entire statement in English into mathematics. We have dP upon dt is equal to R% into P. This is given to you. If the interest is compounded continuously at 5% rate per annum, in how many years will rupees 100 double itself? That is what we need to find. Initially, if you have rupees 100, you wish to get rupees 200. Then, if the rate is 5% which the bank is charging, then in how many years? Okay, so T years will be the answer, some T years. In how many years will this happen? Now, as I said, take P to be the principal, T to be the time, R to be the very rate or R% to be the rate per annum, and P obviously is the principal. So, let's start the question's proof. Now, if the very equality which was given to us is interpreted nicely, there's nothing in this question. So, we are given that dP by dt is R into P upon 100, right? R% was interpreted as R upon 100 into the P, which is the principal. Can I write this as dP upon P equals R upon 100 into T? Now, what is this? Well, again, a concept comes to rescue. If we can write the differential equation in this form, how? If we can write it as f of y dy equals f of x dx. Somehow, if we can write our differential equation in this form, implies that this is a variable separable form. And then, just the strategy which is supposed to be adopted in the variable separable form has to be adopted over here. Over here you can see that this is f of p, which is 1 by p into dp, equals f of t into dt. Is there a dt over here? Well, of course, this is dt. So you have f of t into dt. F of t is r upon 100 into 1. Basically, it's a constant function into dt. So you have f of p into dp, where fp is 1 upon p. And here you have f of t into dt, where this f of t is r upon 100, constant function. Once you have this, that means this is nothing but it's here in the variable separable form. And now we know what is supposed to be done. Integration. This becomes what? 1 by p dp becomes log p. This is equal to r upon 100 into t plus this constant of integration. Now, once I have obtained this, how to proceed? Well, let the initial principal be equal to P naught. Now, when I am saying initial principal is P naught, this means what? That is at time 0, when the time is 0, principal amount is equal to P naught. So, at time 0, principal is P naught. Plug that in this equation. What you get log of P naught is equal to r upon 100 into 0, because time is 0, then principal is P naught, plus c, and you get that log of P naught is what is your c. That means then 1 becomes, what does 1 become? It becomes log p equals r into t upon 100 plus log p naught. So I can bring this log p naught over here. This becomes log p minus log p naught, which makes it log of p upon p naught equals r into t upon 100. And now we need to go back and see the question. Well, the question basically said that 5% is the rate, 100 is your initial principal amount. In how many years will it double itself? So basically my initial principal is given to be 100. P naught is 100. The final principal is double of 100, which is 100 plus 100, or 2 times 100, which is 200. And the rate r upon 100 is given to be 5%, which is 5 upon 100. So r is 5. Plug these values, you get what? Log of p upon p naught, which is 200, upon 100 equals 5 upon 100 into t. This brings you 20, and you get that t is equal to 20 log 2 years. If you wish, you can find out the exact value of log 2 and multiply it with 20. This is going to deliver to you the exact answer of this particular question. This is how you deal with such questions. Note this down, and then we are going to continue our session and see what is the next question. Okay, students. So did you understand, just by the very logic of detecting our very expression that it is in the variable separable form, we could successfully then apply the strategy of the variable separable form and attain our very solutions. You just need to keep in mind the ideas which I am basically pointing out by writing them in the form of concept. The 10th question is saying what? It is saying the total cost associated with the production of X units of an item. X units of an item is given by this. The cost of production of X units of an item is given by this function. So cost is a function of units of items produced. You produce more units, the cost is dependent upon them, and that is how their relation is exercised over here in this particular function. Find the marginal cost when 3 units are produced. So when X is equal to 3, Then find the marginal cost, where they have given you the meaning of marginal cost. It is nothing but the instantaneous rate of change of total cost at any level of output. Now you should know that marginal cost is the rate of change of the total cost with respect to the output produced. The moment that is clear to you, you have to just interpret that in the form of mathematical equation. What did I say? The change, the rate of change of cost, total cost with respect to the outputs produced is what is your marginal cost. So marginal cost is d by dx, because x units are produced. X is the variable standing for the units of items being produced, the output being produced, and cost is a function of x. So this is a valid expression. I have rate of change in the total cost with respect to the outputs produced. Now we are given Cx. What is C of x? It is 0.05 x cube minus 0.02 x square plus 30x plus 500. And then what happens to the derivative? Well, this becomes 0.05 into 3x square minus 0.02 into 2x plus 30 plus 0. And this is what happens to be the equation for, or the function for, marginal cost. Now it is saying what is the marginal cost when 3 units are produced. Now marginal cost, I will write it as m of x. Marginal cost is also dependent upon x. You know what is x. X is equal to 3, so you can find out marginal cost when 3 units are produced. Marginal cost when x units are produced is given by this function. So marginal cost when 3 units are produced is what? This is nothing but 0.05 into 3 into x square, which means 3 square, which is 9, minus 0.02 into 2 into x, which is 2 into 3, that is 6, plus 30. Very simple algebraic expression. You are going to find 30.02 approximately. These many rupees is what is your marginal cost when 3 units are produced. That is what? That is how easy basically this question is, just asking you to be able to convert the English language into mathematics. That is how funny it is, and the moment you do is, it is simple differentiation, which is just giving you a function and then you plug in the value of x over there and you get your very answer. Once this question is tackled with, let's see what happens to the next question of section B. Next question says, find the value of this trigonometric expression. It is actually involving an inverse trigonometric function, which is cot, and a tan. Find the value of this particular expression. Let's get started. Tan of cot inverse minus 2 by 3. The first thing that you can see is cot inverse of a negative term is given to you. Now minus is there, so 2 by 3 is positive, minus 2 by 3 is negative. You know the very concept which will be used over here is regarding what is the formula for cot inverse of minus x. Cot inverse of minus x is pi minus cot inverse x for every x belonging to the domain of cot inverse, which is the collection of all reals. And so cot inverse of minus 2 by 3 will turn out to be pi minus cot inverse 2 by 3, because 2 by 3 is very much a real number, obviously. Now that this is the case, what happens over here? This is tan of pi minus something. What is this? Well, what do I mean by tan of pi minus theta? What happens here? Haven't we studied this in allied angles? Yes, of course you know that. Tan of pi minus theta, the moment you see pi, you don't have to change tan. But the question is, what happens to the sign? Is here a positive sign or a negative sign? Well, pi minus theta lies in the second quadrant, in which only sine and cosec are positive, tan is negative, and so this becomes minus tan theta. That is why tan of pi minus this particular angle is minus tan of this particular angle. Once this much is accomplished, what I need to do next? Now you have cot inverse 2 by 3. If you remember, we have done a property that tan inverse 1 by x is cot inverse x whenever x is greater than 0, and it is minus pi plus cot inverse x whenever x is less than 0. Over here the input is 2 by 3, which is positive, and that is why cot inverse of a positive input is tan inverse of the reciprocal of that input. So cot inverse 2 by 3 will become what? Because it is positive, this will be minus tan inverse of reciprocal of 2 by 3, which is 3 by 2. Very simple. I just use this particular property. Now what do I do next? I have a tan inverse. I very much feel like cancelling them out. But when can I do that? The rule is tan of tan inverse x is equal to x. When does this happen? When does my curiosity of cancelling tan and tan inverse out get satisfied? I can cancel them out, basically write an x only when this x is coming from the domain of tan inverse, which is the collection of all reals. Is this the domain of tan inverse? Well, tan is a function from minus pi by 2 to pi by 2 open interval to the collection of all reals where it is bijective. And so the domain of tan inverse comes out to be the collection of all reals. This is where it is true. And over here, because 3 by 2 is very much a real number, so I can write tan of tan inverse 3 by 2 will be just 3 by 2. This minus sign will be carried forward, and this happens to be your solution. We have solved this particular expression and found out its value. It has come out to be this very simple real number, which is minus 3 by 2. That's how so many logics and concepts, the properties were used to deal with this very simple question. You need to keep the idea of all of them. See, so many properties are getting applied to one single question. That's how questions are framed. They frame the question so that most of the concepts arrive in just one question and they are able to test you upon all of them. You need to keep knowledge of all of these. Let's see what happens to the last question of section B. It is saying solve for x. Again, this is related to inverse trigonometry. Let's see what this is trying to say. It's written sine inverse x whole square minus cos inverse x whole square is equals to pi square by 2. Now, first thing you have to understand, I need to find those values of x which when you plug in inside this left hand side, you get pi square by 2 on the right hand side. That's the question. Find those x's which when plugged in on the left hand side, this is your left hand side, give you the output as pi square by 2. Now, one thing you have to understand and keep in mind that sine inverse x and cos inverse x are only defined for those x's which lie in minus 1, 1 closed interval. So, definitely my x is belonging to minus 1, 1 closed interval, otherwise this won't have been definitely defined only. That means the values of x's which we are going to find as the solutions will definitely be points inside minus 1, 1, for which this equation will be satisfied. Now, the concept that you need over here is what? Let's get started with the solution and then I'm going to tell you what that concept is. Now, you know a square minus b square is what? A minus B multiplied by A plus B. This is equal to pi square by 2. Do you recall something from this expression? Well, there is a very famous property which is sine inverse x plus cos inverse x equal to pi by 2 for every x belonging to the common domain of sine inverse and cos inverse, which is -1, 1 closed interval. That is what is the case. Over here, I can see something like that. Why not just write pi by 2 in place of this and get a simplified expression? So this thing is replaced by pi by 2. What you get is pi by 2 sine inverse x minus cos inverse x equals pi square by 2. This is how it's simplified. Now I don't want sine in picture. So obviously sine inverse basically. So cos inverse is equal to what? Or sine inverse is pi by 2 minus cos inverse x. So sine inverse can be written as pi by 2 minus cos inverse x minus this cos inverse x already present. And this is equal to pi square by 2. What do we do next? This is pi by 2 minus twice of cos inverse x. And this pi by 2 outside, this is equal to pi square by 2. Once we have simplified this, just multiply this pi by 2 to both the expressions inside the braces. You get pi square by 4 minus this 2 gets cancelled. You get pi cos inverse x equals pi square by 2. And now what happens? Well, you can take that cos inverse that side. You get pi square by 4 minus pi square by 2 equals pi into cos inverse x. That's what you have. You have pi square by 4 minus pi square by 2. Let's see what happens next. You have pi squared by 4. Sort out the left hand side. Pi squared by 4 minus pi squared by 2. This gives you 4 as the LCM. You get pi square minus 2 times pi square. This is equal to pi times cos inverse x. Now what is this? This is minus pi squared by 4 equals pi cos inverse x, which basically this pi gets cancelled with 1 pi and you get cos inverse x is equal to minus pi by 4. What do you think is wrong over here? You are getting cos inverse x is equal to minus pi by 4. That means you're getting cos inverse x is a negative quantity. But we all know that cos inverse x is a function from -1, 1 to 0, pi. It accepts inputs from this interval and always sends them in this interval. That means the output produced by cos inverse is always greater than equal to 0 and less than equal to pi. It is never negative, it is always non-negative. That means if there is an x which is satisfying our very equation which was given in the question, then for that particular x, cos inverse x will have to be negative. But cos inverse x is never negative for any x. That means there is no x which is satisfying our very equation. There does not exist any x, and that is why, because this is not possible, therefore there does not exist any x which satisfies absolutely no solution exists in this case because there is no x which satisfies this trigonometric equation. Because if it would have satisfied, I would have got that cos inverse of that x is negative, which is not possible. And that's how we deal with this question. Answer is that there is no x which satisfies that equation. This completes our discussion about section B. We're through with section A and section B. You are advised to solve all of them, practice them hard, and be prepared for these questions.